This is Pluto, the ninth planet from the Sun. Or at least that's what they told us.
For most of the 20th century, Pluto sat quietly at the edge of our solar system, a tiny point of light that most people accepted without question as the ninth planet. Children memorized its place in the planetary lineup. It appeared on posters and textbook diagrams. It had a name, a discoverer, and a story. It was, by all accounts, a settled matter. Then two things happened in the same year that permanently changed Pluto's place in the public imagination. In 2006, the International Astronomical Union voted to strip Pluto of its planetary status, reclassifying it as a dwarf planet and effectively erasing it from the official roster of worlds in our solar system. The decision sparked genuine public outrage, an unusual response to an astronomical classification debate, but a testament to how personally people had taken ownership of this distant little world over the decades. And in that same year, almost as if in direct defiance of the demotion, NASA launched a spacecraft called New Horizons on a journey to visit Pluto for the first time in history. 9 years later, New Horizons arrived, and what it found changed everything. The scientists who sent that spacecraft to the edge of the solar system expected to find a dead, frozen, featureless world, a cold relic of the early solar system that had been sitting unchanged in the dark for billions of years. What they actually found was something so surprising, so geologically active, so visually extraordinary, and so scientifically puzzling that it rewrote our understanding of what small worlds in the outer solar system can be. This is a story of what NASA found on Pluto, and why it matters far more than most people realize. Before we get into the discoveries themselves, it is worth taking a moment to understand why Pluto was reclassified in the first place, because the reason is actually fascinating, and it sets the context for everything New Horizons revealed. When Clyde Tombaugh discovered Pluto in 1930 at the Lowell Observatory in Arizona, he was searching for a hypothetical massive object believed to be disturbing the orbits of Uranus and Neptune through its gravitational influence. Astronomers of the era called this hypothetical body Planet X. And when Tombaugh spotted a faint moving point of light beyond Neptune after months of painstaking photographic surveys, the scientific community declared the search over. A new planet had been found. The planet definition in use at the time was relatively simple, an object orbiting the sun that appeared unique in its region of space. Pluto met both criteria, as far as anyone could tell. It orbited the sun, and from what telescopes of the 1930s reveal, it appeared to be alone out there beyond Neptune, a solitary world in an otherwise empty region of space. That assumption turned out to be spectacularly wrong. Over the following decades, and accelerating dramatically in the 1990s and 2000s, astronomers began discovering that the region of space beyond Neptune was not empty at all. It was populated by thousands of objects, a vast ring of frozen material left over from the formation of the solar system, stretching from roughly 30 to 50 astronomical units from the Sun. This region is called the Kuiper belt, and Pluto is simply its largest and most reflective member. Not a unique planet, but the most prominent object in a crowded neighborhood. The International Astronomical Union's 2006 decision updated the definition of a planet to require that the object must have gravitationally dominated its orbital neighborhood, clearing out other similarly sized objects over time. By that definition, Pluto clearly does not qualify. It orbits within the Kuiper belt, surrounded by thousands of comparable objects, many of which share similar orbital characteristics. Pluto is not the master of its domain. It is a distinguished resident of a very crowded one. But here's the paradox at the heart of Pluto's story. The reclassification that seemed to diminish it actually made it more interesting. As a planet, Pluto was the smallest and most distant member of a family, unremarkable at the bottom of the planetary hierarchy. As the king of the Kuiper belt, it became something genuinely unique, the most complex and scientifically rich example of an entirely new class of worlds that we had barely begun to understand. New Horizons was sent to show us exactly how extraordinary that class of worlds could be. Getting a spacecraft to Pluto is an exercise in patience, precision, and creative use of the solar system's gravitational architecture. Pluto sits at an average distance of roughly 39 astronomical units from the Sun, 39 times further from the Sun than Earth is. At that distance, even a fast spacecraft faces a journey measured in years rather than months. New Horizons was built by the Applied Physics Laboratory at Johns Hopkins University and launched in January 2006 aboard an Atlas V rocket equipped with additional solid rocket boosters that pushed the spacecraft to the highest launch velocity ever achieved by a human-made object departing Earth at that time. New Horizons was moving so fast that it passed the moon's orbital distance in just 9 hours, a journey that took the Apollo missions approximately 3 days. Even at that extraordinary speed, Pluto was too far away for a direct transit to make good time. Mission planners designed the trajectory to include a close flyby of Jupiter, using the giant planet's gravitational field to execute a slingshot maneuver that added additional velocity and bent the spacecraft's path toward the outer solar system. Jupiter's gravity accelerated New Horizons by several kilometers per second, effectively years of additional rocket burn provided for free by the solar system's largest planet. The Jupiter encounter in 2007 also served as a valuable science opportunity. New Horizons tested its instrument suite by photographing Jupiter and its moons in detail, returning spectacular images, including a photograph of an active volcanic eruption on Io, one of the most volcanically active bodies in the solar system, that demonstrated the spacecraft's imaging systems were performing exactly as designed. After Jupiter, the journey settled into the long, quiet transit through the outer solar system. For most of this time, New Horizons was placed in hibernation, its systems powered down to minimum levels to reduce wear and conserve the spacecraft for its primary mission. Mission controllers would periodically wake the spacecraft for system checks, but for most of the 8-year journey from Jupiter to Pluto, New Horizons was essentially sleeping its way across the solar system. In early 2015, the spacecraft was brought back to full operational status and began its approach to the Pluto system. At first, Pluto and its largest moon Charon appeared as nothing more than two closely spaced bright dots in the spacecraft's cameras. But as the weeks passed and the distance closed, those dots resolved into disks and then into worlds. What the cameras began to reveal as New Horizons closed the final millions of miles to its target was unlike anything the science team had anticipated. The first thing that struck scientists and the public alike when New Horizons began returning high-resolution images of Pluto's surface was the color. No one had expected Pluto to look like this. The popular imagination had conjured a gray or white ball of ice, cold, uniform, and geologically dead. The reality was a world of extraordinary visual complexity, painted in shades of deep burgundy red, pale blue-gray, cream white, burnt orange, and bright yellow. Pluto looked less like a frozen rock and more like an alien landscape of staggering variety. The most immediately striking feature was a vast, pale region covering a significant portion of one hemisphere in a shape that bore an unmistakable resemblance to a heart. This feature, formerly named Tombaugh Regio in honor of Pluto's discoverer, quickly became the iconic image of the New Horizons mission. But as visually arresting as the shape was, the science beneath it proved even more remarkable. The western lobe of the heart, a smooth, flat plane of frozen material formerly designated Sputnik Planitia, turned out to be one of the most geologically extraordinary surfaces in the solar system. It covers an area roughly comparable to the state of Texas and is composed primarily of nitrogen ice, not water ice, which at Pluto's surface temperature of approximately negative 229 degrees Celsius would be as hard and unyielding as granite, but nitrogen ice, which remains pliable enough at Pluto's temperatures to flow and convect. The surface of Sputnik Planitia is divided into a mosaic of irregular polygonal cells, each one ranging from several kilometers to tens of kilometers across. These cells are the surface expression of convection currents operating within the nitrogen ice, a process in which warmer material from deeper within the ice sheet rises toward the surface, spreads outward, cools, and sinks again at the boundaries between cells. The energy driving this convection comes from heat still radiating from Pluto's interior, and the process is ongoing. Sputnik Planitia is not a frozen, static landscape. It is a slowly churning, actively renewing surface that erases impact craters almost as quickly as they form. This was the first enormous surprise of New Horizons. Pluto, a world less than a quarter the diameter of Earth sitting billions of miles from the Sun, was geologically active, not in the distant past. Right now, the geological activity of Pluto did not stop at Sputnik Planitia. As New Horizons mapped the surrounding terrain, it revealed evidence of glacial flow, nitrogen ice moving slowly downhill from the highlands surrounding the heart into the low-lying plains, carving channels and leaving streaks in the surface that documented its passage. The same process that produces glaciers on Earth, gravity pulling material downhill over time, was operating on Pluto, with nitrogen ice playing a role that water ice plays on our own planet. At the margins of Sputnik Planitia, where the flat plain meets the rugged highlands, New Horizons photographed mountain ranges with peaks reaching several kilometers above the surrounding terrain. These mountains are composed of water ice, which, at Pluto's temperatures, behaves like rock, rigid and structural, providing the foundation for the towering peaks. The visual contrast between the smooth, pale plain and the jagged, dark mountain ranges surrounding it created some of the most dramatic landscape imagery ever returned from another world. Pluto also turned out to have an atmosphere, thin, layered, and hauntingly beautiful in the backlit images captured by New Horizons as it looked back toward the sun after its closest approach. The atmosphere is primarily nitrogen, with traces of methane and carbon monoxide, and it extends remarkably far above the surface because Pluto's gravity is too weak to hold it close. The atmosphere forms in layers of haze that refract sunlight into blue tones, giving Pluto a faint sky color that no one had predicted. The interaction between this atmosphere and the radiation streaming from the sun produces one of the most visually striking features on Pluto's surface. Ultraviolet radiation from the sun breaks apart methane and carbon dioxide molecules in the upper atmosphere, generating complex organic compounds called tholins. These molecules clump together, turn a dark reddish-brown color, and gradually settle out of the atmosphere onto the surface like a slow, continuous rain of organic material. The deep red stain covering a large swath of Pluto's surface, the region informally called Cthulhu Macula, is the accumulated product of billions of years of this atmospheric chemistry, painting the landscape in progressively darker and redder tones. Tholins are significant beyond their visual impact. They are the same class of organic compounds that are believed to be present on many outer solar system bodies, including Saturn's moon Titan, and they represent a form of prebiotic chemistry, the kind of molecular complexity that, in the right environment, could potentially contribute to the emergence of life. Finding them on Pluto does not suggest life is present there, but confirms that the chemistry leading toward biological complexity is not confined to the inner solar system or to warm, sunlit environments. Among the most scientifically puzzling discoveries made by New Horizons was evidence of cryovolcanism, volcanic activity powered not by molten rock, but by pressurized water, ammonia, or other volatile compounds erupting from a warm interior. The most prominent example identified in New Horizons data is a structure called Wright Mons, a broad, gently sloping mountain approximately 5 kilometers tall and 150 kilometers in diameter, with a central depression consistent with a volcanic caldera. Wright Mons bears almost no impact craters on its surface, a strong indication that the feature is relatively young in geological terms and has been resurfaced recently enough that the steady bombardment of the Kuiper belt has not yet had time to leave a visible record. Something is actively refreshing the surface of this structure. The most plausible explanation is periodic eruptions of a slushy mixture of water ice and other volatile compounds from the interior, coating the surface with fresh material and erasing the crater record. The existence of cryovolcanism on Pluto raises a question that planetary scientists are still working to answer. Where does the energy come from? Cryovolcanism on the moons of the outer solar system, Europa, Enceladus, Titan, is driven by tidal flexing, the gravitational squeezing and stretching caused by orbiting close to a massive planet. But Pluto has no massive planetary neighbor to squeeze it. The only gravitational influence comparable in scale is Charon, and while the unusual mutual tidal locking between Pluto and Charon likely played a role in Pluto's thermal history, the degree to which it can account for Pluto's current internal warmth is not fully understood. The broader implication is deeply interesting. New Horizons data suggests that Pluto may harbor a liquid water ocean beneath its frozen surface, a subsurface ocean kept liquid by internal heat that has not yet fully dissipated since the solar system's formation, and possibly supplemented by the energy of radioactive decay in Pluto's rocky core. If this interpretation is correct, Pluto joins a growing list of outer solar system bodies, Europa, Enceladus, Titan, and possibly others, that maintain liquid water oceans beneath frozen surfaces, raising profound questions about where in the solar system habitable conditions might exist. No account of what New Horizons found at Pluto will be complete without its largest moon, Charon, which New Horizons photographed in comparable detail to Pluto itself. Charon is roughly half the diameter of Pluto, an extraordinarily large moon relative to its parent body, comparable in relative terms to having a moon the size of Mars orbiting Earth. The relationship between Pluto and Charon is unlike any other moon-planet pair in the solar system. Because Charon is so large relative to Pluto, the gravitational center of the system, the point around which both objects technically orbit, lies not inside Pluto, but in empty space between them. Both Pluto and Charon orbit this common center of gravity, making the system in some ways more like a binary dwarf planet than a traditional planet-moon arrangement. Both objects are tidally locked to each other. Charon always shows the same face to Pluto, and Pluto always shows the same face to Charon. From a Charon-facing side of Pluto, the moon hangs permanently fixed in the same position in the sky, neither rising nor setting, day after day across billions of years. Charon's surface tells its own surprising story. New Horizons revealed a large reddish stain covering much of Charon's north pole, material that spectral analysis identified as tholins similar to those found on Pluto's surface. The most likely explanation is that volatile compounds escaping from Pluto's atmosphere are captured by Charon's weak gravity and accumulate over time at the pole, where they undergo the same radiation-driven chemistry that produces tholins on Pluto itself. Pluto and Charon are, in a very real sense, chemically connected, one world seeding the other with organic material across the space between them. The New Horizons flyby of Pluto lasted only a matter of days before the spacecraft's velocity carried it past and onward into the deeper Kuiper belt. But the data it collected during those days has kept planetary scientists busy for nearly a decade and will continue to yield new insights for years to come. What Pluto taught us goes far beyond the specifics of one small world at the edge of the solar system. It demonstrated that geological activity, atmospheric chemistry, and potentially even liquid water are not confined to the warm inner planets or the tidally heated moons of gas giants. They can exist far out in the cold, dark reaches of the solar system, in bodies far smaller than anyone thought capable of maintaining the internal energy required. It showed us that the definition of a potentially habitable environment, a place where the conditions for life as we know it might exist, is considerably broader than our Earth-centric intuition suggested. And it revealed that the solar system's outer regions, long dismissed as a cold, featureless void populated by inert frozen relics, are actually a frontier of surprising complexity and geological richness. Pluto is not the ninth planet. It never really was. But it is something arguably more interesting. The most complex and best studied example of an entirely new class of worlds, a window into the outer solar system's hidden vitality, and a reminder that in space, the places we expect to be boring almost always turn out to be anything but.